In this video, I'm going to go over the questions from the second review for exponential and logarithmic functions. So the first four questions are asking us to take these logarithmic equations and rewrite them as exponential equations. This is where I've focused on having you guys think of doing swoop, where you're going to swoop around to rewrite these as exponential equations. So this first one says log base 3x of x squared plus 4x plus 15 equals 2. So we're going to start at the base, swoop around to get to that argument. So it's going to be 3x raised to the second power equals x squared plus 4x plus 15. All right, I'm actually going to make this 3x in parentheses so you know that whole thing is a base. All right, and that's it. That's all you have to do for that one. Let's do the same thing for number 2. This one's a little trickier because there's no base, but it says ln, which represents the natural logarithm. So the base for that is going to be an e. So it's e raised to this power equals the 3x plus 9. So e to the 2x minus 3 power equals 3x plus 9. Okay, the next one, another one that doesn't have a base, but this is log for the common logarithm, which has a base of 10. So 10 to this power equals that argument of x. So 10 raised to the x minus 3 power equals x. And the last one has a base. In this case, it's 4. So 4 raised to the 2/3 power equals that argument. So 4 to the 2/3 power equals x plus 7. And that's it for those first four, changing from logarithmic equations to exponential equations. All right, let's try the next four. Are also going to feel very similar, except this time it doesn't tell us what the answer is, right? And because these are logarithmic equations, our answer you're going to see is just the exponents. So I'm going to rewrite it like this. And then if I swoop around, I'm going to have 2 to some power gives me 16. So 2 to some power gives me 16. All right, so 2 to the 4th power is 16. So you can just write 4. You could also write, if you wanted to, log base 2 of 16 equals 4. This would also be true. All right, but for the test, all I care about is seeing that number, right? That is the exponent of your exponential equation. Let's try number 6. So number 6, I rewrite it, log base 3 of 3 equals something. Change it to exponential form. 3 to what power gives me 3? Now you should see this is going to be 1. And one rule or property that you can memorize, if the base and the argument are the same, so in this case the base was 3, the argument was 3, if those numbers are equal to each other, then the logarithm will always be equal to 1. Okay, the next one, log base 8 of 64 equals something. Swoop, change it to exponential equation. So 8 to some power equals 64. 8 to the second power is 64. And the last one, written out, log base 6 of 216 equals something. Change it to the exponential equation. 6 to some power equals 216. So how many 6's do you need to multiply to get 216? Let's see, 6 squared is 36. 36 times 6 is 216, so 3 of them. And that's it for the next 4 questions. All right, the last questions here are going to be about condensing and expanding the logarithms. So you'll notice in 9 through 12, we have 2 logarithms that I'm going to be writing as 1, and then the next 4, 13 through 16, is the same thing, but going backwards. So I try to mention this to you guys when we practice this, but if I see subtraction, I should be thinking division. When I see addition, I'm thinking multiplication, and vice versa there. So this first one I notice is going to be division, but I do have this 5 that's in front. So I'm going to rewrite that 5. Oop, that's not it. Log of k minus, so I'm going to write the log of g, but raised to the 5th power. So move that number to become a power first. And now I can write this as 1 log And my argument is going to be division, where k is on top and g to the fifth power is on bottom. So that is my answer for number 9. Let's do number 10. Number 10, again, I have a number that's in front. Let's move it to be a power. So log of d cubed plus log of g. I see addition, so I'm going to put these together by using multiplication. So my argument is going to be d cubed times g. You could write the dot for multiplication. You don't have to, but this is going to be the answer for number 10. Number 11, this time I don't have a number in front. I have another variable, but it's the same process. Move it to the power. So it's the log of q raised to the power of z. I see addition, so I'm going to use multiplication here. So c times q to the power of z is my argument. That's number 11. And the last one, number 12, I've got 2 instances of things in front, so move those to become power. So it's a squared minus the log of d to the z power. I'm going to have division. The numerator is a squared, and the denominator is d to the power of z. So that's it for number 12. All right, so those 4 were about going from 2 logs and rewriting them as 1 log. The last 4 questions is going to go the other way. They're giving it to you as 1 log with an argument, and we're going to expand these arguments to be 2 logs. So the way I think of this is the 9 is separate from the x to the 5th power. So you'll notice I separated those into 2 separate logs. The operation in between 9 and x to the 5th power is multiplication. So when I see multiplication, I'm going to write addition. And the way you're going to get this to be fully correct is to move that 5 that's in the power to the front of that log. So this is what I'm looking for number 13. 14, same thing. I see multiplication. So split them into 2 logs. So log of x cubed, log of y to the 5th power. It's multiplication, so I'm writing addition. And then move those numbers that are in the exponents to the front, and you'll be finished. All right, last 2. These last 2 are both division, so you'll see I'm going to use subtraction. So log of x cubed, log of y squared, going to be subtraction. And then move the powers to the front to get this fully simplified, I guess fully expanded. All right, so that's this one here. And then finally, the last one, log of x and log of y cubed connected with subtraction. The x doesn't have a number up there, right? It's x to the 1st power, so you just leave that as it is. But you're going to move that 3 to be in front of the log of y. Okay, so these are the questions from the second review. And don't forget to, if you want to practice anymore, you can find those Delta Math links for these lessons from 6.3 and 6.5. Good luck.